Hello everyone, welcome to the 10th lecture of this series. In this video, we are going to see 10 MCQ questions. So let's get started.
And before we start, I would really appreciate it if you could smash that like button, drop me a comment, and share this free program with anyone who might need it.
So the first question is deformation of a bar under its own weight when compared to that when subjected to a direct axial load equal to its own weight will be what? So in the first case, let us say this is my bar and it is subjected to deform to its original weight itself. So in the second bar, we are applying an axial load, an external load W, and we are finding. So for this, what will be my answer? It will be W L by AE. Change in length due to axial force is equal to PL by AE. So this is our answer we know. So since P is equal to W, it is WL by AE. And when we come to this deformation under its own weight, it will become delta L is equal to WL by 2 AE. Here P will act as W by 2. So we know this formula also, this also. So when we compare these both, we can see that deformation due to its own weight is half the times that of deformation due to axial load. So the answer is half. Next question, a tapering bar of diameter end sections being D1 and D2. So say this is my tapering bar D1, D2 and the bar of uniform cross section D have the same length and are subjected to the same axial pull. Both bars have the same extension if D is equal to what? So the condition is the deformation should be equal of 1 is equal to 2. It should be equal. So when I do this, this will become PL by AE is equal to PL by AE. So we know that the length is the same, the load is the same, elastic modulus is the same. So this becomes, so area of 1 will be equal to area of 2. It should be like that for the deformations to be equal. So area of the first bar, let me take this bar, it will be pi by 4 into d square. The second bar will be pi by 4 into d1 into d2. So I can cancel this. So from this I can get that they have asked what is the value of d. So d should be equal to d1 d2 square root of. So the answer is option B. Next question, a cube having a side length A. So this is my cube constrained in all directions and is heated uniformly so that the temperature is raised to T degree centigrade. If alpha is the thermal coefficient of expansion of the cube material and E is the modulus of elasticity, the stress developed in the cube is what? So if it had been a bar, when we consider it in 2D, then we can consider the strain of the material to find the stress. But when we come for a 3D material, we have to take into account the volumetric strain and not just the axial strain. So we know the formula for volumetric strain. It is equal to sigma by E into 1 minus 2 nu. So from this, if we calculate the value of sigma, because they have asked the stress only. So sigma is equal to E into volumetric strain divided by 1 minus 2 nu. So you don't have to go and calculate this. You can just compare the value of this with the options given. So you can see that there is only one option with 1 minus 2 nu. So this is your answer. Next question. The toughness for mild steel rod under uniaxial tensile load is given by the shaded portion of the stress strain diagram as shown in which one? So the answer is, since they have asked for toughness, the answer is option D. We know that toughness is considered till the fracture. But if it had been resilience, then the answer is option A, because for resilience we will take only till the elastic limit. Next question, the value, which one of the following is correct for the Poisson's ratio's value? So we know the maximum value for Poisson's ratio is 0.5 and the minimum is -1. Therefore, the answer is option C. Next question, a bar of copper and steel form a composite material. So say this is my copper and this is my steel. They both form a composite material. They are heated at a temperature of 40 degrees centigrade. What type of stresses is induced in the copper bar? So the shaded bar is going to be my copper bar. So they are asking what type of stress. We know that the thermal coefficient of copper is greater than thermal coefficient of steel. What does that mean? This means that copper will expand more for a given temperature. Say for a given temperature of 40 degrees centigrade, copper will expand more than that of steel. So what will happen if one material wants to expand but the other material is not allowing it to expand? Say this is steel, this is copper. Copper wants to expand but steel is not allowing to expand. And since they both are composite material, the change in length should be the same for both the materials. So because of this, compressive stress will act in copper to make sure that the change in length is same in both the materials. So the answer is compressive stress. Next question, cube with side length 1 centimeter. So heated uniformly to 1 degree centigrade above the room temperature and and all the sides are free to expand. Okay. What will be the increase in the volume of the cube? The coefficient of thermal expansion is alpha per degree centigrade. They have asked what will be the increase in cube. So they have asked for delta V, that is change in volume. So let us look into the change in length in all the sides. So we know that volumetric strain is equal to change in volume by total volume. So they have asked for change in volume. So change in volume is equal to, since it is a cube, again we have to take volumetric strain only into account. So the change in volume is equal to volume into volumetric strain. So what is the volume of 1 centimeter side cube? It is 1 centimeter cube. So this becomes 1 into, we have to find what is the value of the volumetric strain. So volumetric strain for a 3D thing is strain in x plus strain in y plus strain in z direction. So what is the strain in x direction? Strain is equal to in length by original length, which is L alpha t divided by L. So strain becomes alpha t, and we know that T is equal to 1 degree centigrade and alpha is just alpha. So this means that Ex is equal to alpha, and same, it is the same for all the three sides. So it is alpha plus alpha. So volumetric strain becomes 3 alpha. So when I substitute the value here, I can see that delta V is equal to 1 centimeter cube into 3 alpha. So my answer is 3 alpha centimeter cube. So the answer is option A. Now to the next question. E, G, K denote Young's modulus, modulus of rigidity, bulk modulus respectively for an elastic material. Then which one of the following can be possibly true? We have E, G, K and another elastic constant is nu. So let me write all the relation between them. E is, so these are all the relation, and from this they have asked which one of the following is correct. So let us take option A. G is equal to 2K they have told. So let me see where G and K comes here. So these both are quite complicated. So quite obvious that G cannot be equal to 2K. So going to the next option, G is equal to E they are telling. So let me take this relation. So if E should be equal to G, then this term should be equal to 1. Let us see if this can be equal to 1. This means 2 into 1 plus nu should be equal to 1. And we know that mu, that is Poisson's ratio, it can take value from -1 to 0.5. Therefore, this is possible. So option B is possible. Let us come to option C. So let us take the second relation into account. So this is also possible because it lies between this limit. Therefore, C is also possible. Next, G is equal to K is equal to E. So this one is not possible. So these two things are possible. Next question, consider the following statements. So strength of steel increases with carbon content. Is it true? Yes, it is true. If we take Fe250 and Fe500, difference is the carbon content in them. Because of the increased carbon content, the yield strength of Fe500 has increased. So this one is true. So 1 is true, therefore I can eliminate this answer. Young's modulus of steel increases with carbon content. So now Young's modulus comes into account. We know that even for Fe250 and Fe500, E remains the same. It is 2 into 10 power 5 only. Therefore, it does not hold true. This answer is not correct. Therefore, you can eliminate this. Now coming to the third option, Young's modulus of steel remains unchanged with the variation of carbon content. That is correct. The answer is not only 1 but 1 and 3. Option D. Next question. A solid uniform metal bar of diameter D and length L is hanging vertically from its upper end. The elongation of the bar due to self-weight is what? Normal elongation is equal to PL by AE. So here P is equal to my weight, so it is WL by AE. So they asked what is it proportional to. So from here directly you shouldn't like substitute the value of A alone, you should substitute the value for W also. So what is the weight of this bar? The weight of this bar will be cross-sectional area into length of the bar. So let me substitute it here. So area into length divided by AE. So looking at the options, option D is correct. So with this we come to the end of the video. I hope you found this useful. In case you did, please do like it and share it, and please do subscribe to my channel. I am posting videos almost every day. So thank you so much for watching guys, and don't forget to click that notification icon also. See you guys. Tata. Bye bye. Take care.